Okay, so this is lesson 12, investments with additional principal. Okay, so it's kind of like looking at like the idea behind this is like a savings account effectively. So you have two things adding to the account. So you have the interest component, which the bank is adding, all right, and then we're going to be looking at also payments which you're adding to your bank account as well to make it increase in the savings. All right, so that's the idea behind this lesson 12 here. Okay, so let's get started. Recursion is probably a pretty good way that we're going to use to model and do an analysis of the investment and also looking at additions to the principal. The finance app is good. There's a few little tricks to it as well that we'll need to show as well. Okay, so a couple of things there. All right, increasing annuity investments. Okay, so at this point, what we've done is we've looked at everything in terms of a loan from a bank. That's meaning that you are paying back the bank. Okay, so largely we'll be looking at this in terms of a subtraction on the end. Now what's going to be happening is that we're actually going to be adding to that, all right, so adding to the investment as opposed to subtracting. So these compound interest investments with additions to the principal. Okay, so what we have is we're adding money to our bank account, right, in order to increase it. We're not trying to reduce it to bring it back down to zero. We are trying to increase it. All right. So as said there, simply put, you're investing a sum of money and then regular putting more money into the investment. Okay. So just a few extra notes with that. All right. Moving on. These are sometimes called increasing annuity investments as opposed to the ones previously that we've looked at, which have been decreasing. Okay. Very easy to confuse with an annuity, which an investment then pays out money of the investment. And obviously, as we saw a few lessons ago, they decrease all the way down to the bottom. All right, so let's keep on going. Consider an investment of $3,000 with an additional $1,500 deposited each year. The investment earns interest rate of 8% per annum compounded annually. So nice, simple one to start off with. So what is happening here is that we have the $3,000. Okay, 8%, which could represent through 1.08. So the interest component has increased that to 3,240 over the year. And then what's happened is that you've also deposited another $1,500 at the end of the year in order to increase it to 4,740. That would represent through V1 or after 1 year. The process would then repeat times by 1.08. Interest is added. And then we have the 1,500 deposit as well. And there's V2. So in terms of a recursive formula, the two things that we're doing, number one is we're multiplying the previous term by 1.08, and we are plussing 1,500 to this. Remembering V0 is equal to 3,000. All right, we've run over this quite a few times already within this lesson, is that we're now looking at this in terms of a plus because we're adding to the loan as opposed to a subtraction, reducing the loan, or possibly a perpetuity. Okay, this is a highly effective way of investing / saving, as the balance of the investment will increase at an increasing rate. So we can see that what's happening in the first year is it has increased by 1,740, which has been 1,500 plus the interest. But then when we compare this to the second year, is that it is increasing by a larger amount. The 1,500 remains the same because that is your deposit each year. But what is changing is that because you are multiplying by a larger number, in other words, in the first year, you're multiplying by 3,000 to the 1.08, whereas this year, you are now multiplying 4,740 by 1.08. So naturally, what's going to happen is that the interest component, which is earned every single year, is going to increase and increase. Okay, Grace plans to travel overseas and finishes year 12. She's already saved $1,200 and thinks that she can save an additional $50 each month that she plans to add to her savings account. The account pays an interest rate of 3% per annum, compounded monthly. Okay, let's have a go at this. Model this investment using recurrence relation of the form like so. This one here is quite nice because the additional repayments of $50 each month lines up with the 3% being compounded monthly. So this is a nice question here. All right, so looking at this in terms of our recursive formula, fairly self-explanatory, is that we're starting with 1200. Okay, so V0 is equal to 1200. The $50 is the plus 50 each time, so that is the value there of D within the question. And the monthly interest rate, we have to divide that out by 12 in order to get 0.25. And don't forget that's as a percentage, so we need to divide that out by 100 and then make sure we are increasing, so we have it as 1.0025. And that is our value of R. Okay, nothing too dissimilar to what we've already done already. Okay, question B to this. Use your calculator to determine recursively the value of the investment after Grace has made 3 additional payments to her investment. So now that you've got this, you can input it into your recursive formulas, all right, in your ClassPad, and simply go down to 3, and you end up with 1359.40, rounding to 2 decimal points. Okay, so recursive is quite good for this. I would probably tend to lean towards using that as my method for these styles of questions. All right, as we continue on, what will be the value of the investment after 1 year? 1 year is equal to 12 months. Once again, scrolling down, and you end up with $1,359.40. Fairly self-explanatory once you've got the recursive formula. Okay, next example. Eleanor invests $500,000 at 5.5% per annum compounded monthly. She makes regular deposits of $500 per month into the account. What is the value of the investment after 5 years? Okay, so now using the finance app for this, it does get a little tricky, so it's up to you whether this sits nicely with you or not. It's your choice. Okay, 500,000, that's fairly self-explanatory. Interpret this as if you are giving the money to the bank, that is the negative component here. It doesn't matter hugely if you look at that in terms of the positive component. It just needs to be making sure that you get the other numbers correct as well in relationship to what you do. 5.5, fairly self-explanatory. The compounding monthly is the CY. Now the $500, previously what we've done is that we have made the PV and the PMT different. However, this time the direction of money is in the same direction. Okay, so what this means is that the $500,000 is you are giving that to the bank, so it's going away from you, and also each month you are giving or adding to that $500,000 from you. Okay, so in other words, the money is traveling in the same direction. If you decide to do these both as plus, that's okay. It doesn't really matter. It just means that your future value will in fact be different. Right, now what is the value of the investment after 5 years? Okay, so just remember, all right, we're doing 500 per month, so the PY is 12, which means that 5 years, we've got to convert that out to 60 months, which is going to be N60. Now we can simply click on our future value. All right, this will appear as the opposite of what we see, okay, as the negatives here, because the money will need to return back to you. So 69292.30 is your solution. All right, that is it. Okay, give these questions a go.